Welcome to another episode of our Some Engineering podcast. Today we have Waldemar Hummer, who is a co-founder and CTO at LocalStack. Waldemar, welcome.
Thanks so much for having me, Lars. It's great to be here in the podcast. Looking forward to our conversation today.
It'll be very exciting. I can tell already. We had a chit chat obviously before this recording. So why don't we start, Waldemar? Tell me a little bit about LocalStack, the problem it solves, and why you created it.
Yeah, sure, absolutely. So LocalStack is essentially a cloud emulator that emulates the AWS APIs on your local machine. So it basically provides a sandbox environment that allows you to develop your cloud applications locally. The reason why this is useful is it actually started as an open source project in, I believe, 2016. Working at Atlassian back in the days. And we sort of had this use case that some of our team members were sort of really sometimes commuting on the train or had some kind of offline work environments. And then they just wanted to be productive there as well, right? Working with cloud apps. And we started, building out a few initial emulators, things like Lambda functions, Kinesis streams, and so on. And then from then on, we open sourced the project on GitHub, I think in 2017, under an Apache 2 license, and it just basically was growing from there onwards, and still continues to be very successful. And today is actually also a company and a team behind it.
Right. So, but it's still open source, though there is another version of the product, right? Is there a downloadable version, or how do I was looking.
Yeah, so it is really, so it kind of ships as a Docker image, which is kind of our primary way to distribute the software. And we have an open source repository. It's localstack/localstack on GitHub, which really contains a set of around 35 services, like really the core services that you would use for your serverless applications, things like Lambda functions, DynamoDB, and a bunch of others. And then we also have a pro version, which has some extensions, a lot of additional APIs and services, which are sort of more for the power users, really, that we also offer.
Got it. Yeah. So I want to go back to this initial use case. You said you wanted to make your colleagues productive while they were commuting, which makes a lot of sense in 2016, 2017. And essentially you said, like, I'm going to give you an AWS cloud on your computer, full blown, same thing. So you can do development. That's pretty much it, right?
Pretty much. And I mean, some people would argue that this is a simply, audacious goal that you can never really achieve, because who comes up with the crazy idea of rebuilding a cloud on your local machine? But it turns out that obviously we initially made a few shortcuts and just made sure that things are working in the best possible way, right? So we can also make shortcuts in a few places. For example, when you think about the networking that's happening internally in the cloud, where you have VPCs and all sorts of different configurations, we don't need to necessarily provide all this complexity, because everything is running locally, as long as we provide the functionality of the services, right? Giving people the ability to run their workflows, their applications locally. And I would say, like, over the years, we've become, much better in terms of, first of all, increasing the parity of what LocalStack is able to do. It also behaves more very close and similar to AWS Cloud, the real thing. And we're also increasingly putting things in place where we actually systematically test this parity. So we have a very comprehensive integration test suite, which includes some parity tests, as we call them, in order to make sure that the behavior is correct and the same.
Mm-hmm. When you say parity, what do you mean by that? Like the number of services you support, or how those services behave on your local machine?
It is essentially like both the syntactic behavior in terms of the correct responses and requests being transmitted, and also the semantics of, like, if you make a certain API request with a certain sort of parameter, that is the effect in the background is actually appropriate and accurate. So and the reason why this is important, so these services are consumed from different clients, right? So it might be just some SDKs if you program it in I don't know, Java or Python or something else. But there's also tools, for example, like Terraform, which are written in Go for the most part. And so these tools tend to be very strict when it comes to sort of the schema validation of the responses. So you need to make sure that all your data types are correct. Sometimes, if you have a date that's not formatted as a string, but as a numeric timestamp, then it might just throw up it might just break the Terraform integration. So that's why the parity is really very important for kind of having compatibility with all the different client systems, basically.
Yeah. So if I'm looking at your website, right, like one of the solutions you offer is this cloud emulation, and I think the word is so appropriate because it's not the real thing, yet it is the real thing on your local machine, right? Like if we go back, we're dating ourselves 20 years, right? Like, there was this thing of an emulator, a Mac emulator for your Windows machine. And so very fitting description. I want to go back to the initial use case again. You said, making people productive on a train, maybe even on an airplane, a transatlantic trip, 9 hours, right? But the obvious question is, COVID came. Everyone went back home, right? So no more commuting. You could argue it's like, well, why not use the cloud directly? Yet, looking at everything, your GitHub stars and your developer engagement, it has only gone up through COVID. So what happened? Something must have changed.
Yeah, that's really interesting. I think one way to explain it maybe is that working from home usually some folks may have maybe not as reliable network connectivity in their local networks, and you still, like, for example, if you develop Lambda functions in AWS, you constantly need to sort of update the code, upload it to the cloud. Sometimes these zip packages can get tens of megabytes, hundreds of megabytes even. And like always constantly uploading them to the cloud just becomes very slow. So I think even with the work from home that was introduced during COVID times, there's still a strong need for what we're building.
Mm-hmm, mm-hmm. So can you talk a little bit about the advantages and benefits of having a local environment or like a local cloud on your computer? What are some of the benefits?
Yeah. So one of the benefits is definitely sort of the agility and efficiency gains you get. So sometimes we speak about sort of the outer loop of development and then the inner loop, right? So the inner loop is really like the quick cycles where you write some code, you write some tests, you execute it, you maybe you debug the code, maybe set a breakpoint. And like this is like very frequent iterations that are happening ideally on your local machine. And then you have the outer loop, which is more like getting your code integrated into the repository, integrating with other services if you have a microservice architecture and so on. But especially focusing on this inner loop is really critical for us to accelerate these cycles. And maybe I can briefly show afterwards in a short demo where if you develop a Lambda function with LocalStack, you can literally, like, it all executes locally. You can make a change to the Lambda function and it immediately is reflected upon the next invocation. No need to redeploy or upload zip files and all that. So it's just a much more. So efficiency and agility is one point. The second one is quality. So it kind of we see that it kind of motivates people to shift left in the literal sense of writing tests from the very first line of code. Because there's no need for any cloud approvals or going through any, of these bureaucratic processes that some companies still have in place to get access to the cloud. So it's really kind of help you increase the quality of your application from the very first line of code. And then the third part is cost savings. That's quite obvious. It's not the most important point that we focus on, but it's a nice side effect also that comes with LocalStack for sure.
Yeah. So agility, quality, and cost savings, right?
Yeah.
So let's double click on each one of them. Agility. I'm thinking of like, okay, I am spinning up an RDS instance with AWS directly, right? That's going to take what? A few minutes? A minute?
Yeah, it's a great example. So it can take up to like 7, 8, 10 minutes in the worst case. Yeah, definitely. There's certain cases or if you spin up an EKS cluster, for example, right? The Kubernetes cluster can take up to 15, 20 minutes to become available. So it's like some of these cases are really very like a natural fit for LocalStack, because you can spin it up and down within a couple of seconds. And also, if you think about so I think one of the interesting points is also, if we sometimes distinguish between like working on, for example, the control plane of an application. So for example, if your task is to create a scheduling API that just provisions infrastructure, and then basically the work that SRE teams and infrastructure and ops teams are often doing. And then more the application side of things, where you really deploy your application logic, develop serverless apps, Lambda functions, and so on. And especially like for both of these cases, I think we have an interesting offering for the control plane, simply because the provisioning is so much faster of your resources, and it can also be mocked out in a few places. And then for the second tier of users of application developers, you just really have these quick cycles of literally running your code on your local machine, setting breakpoints and all that.
Mm-hmm. Great. Yeah. I mean, this adds up, right? We're going from tens of minutes to seconds. It's a game changer. What about the quality aspect and shift left? There's a lot of shift left talking, right? I think Sneak leads with it. Let's talk about that aspect, the quality aspect of my code.
Absolutely. So generally speaking, what we see is that LocalStack is also an enabler for digital transformation, really. So sometimes we work with users and customers who are maybe just starting to go to move into the cloud, right? And migrating workloads maybe from on-premise to the cloud, to start to get productive with their cloud journey. And typically, like when you have a tool like LocalStack, it influences the way how you set up your local dev environment, your CI/CD pipelines, and kind of the entire end-to-end flow. So given the fact that it's so easy to replicate the same environment locally and then your CI pipeline, it becomes literally, you just flip the switch. You can run your tests locally; they work. You can run them in the CI pipeline from the very first line of code, and it's really easy kind of to transition through different phases, basically. So that's what we're seeing there. There's also another aspect of which is interesting. So a lot of developers sometimes get a bit unproductive when it comes to managing all the security policies in AWS. Obviously, they are important, so you need to configure all your IAM policies, make sure that everything is secured. But sometimes it gets in the way of productivity of people, right? So you have to tweak your policy, and something doesn't work with the access. In LocalStack, we have two modes of execution. One is just basically permit all, so you don't need to deal with IAM, because essentially any service can talk to any other service. And then you can also make the switch and say you want to enable IAM enforcement, in which case the actual policies need to be in place and so on. But like this first mode is just very helpful to just get productive quickly and not having to deal with IAM.
Yeah, this makes a lot of sense, right? Because if you're removing all blockers, like let's just figure out if this thing works, right? And then once we figure out if it works, we'll add security and authentication, all that good stuff. At least I get to the point now, okay, I know what I just did works, right? And now we can embed security and privacy and all the good stuff into my code or my process.
I mean, it shouldn't usually come as an afterthought. So we're also, fans of being, adding security into the process. So but I think as an application developer, maybe your primary concern is, okay, I have my SQS queue and have my DynamoDB table and have some event-based application. I need to debug exactly the logic that's happening there. So that's really the part that I want to focus on, and maybe not so much the the concrete setup of the IAM policies, right? That maybe is something someone else can take care of.
Yeah. So then let's talk about, so we covered the agility part with the control plane. We covered just now the quality part. Number two, let's talk about the cost savings part. So obviously, if I'm running stuff on my local machine, I don't have to pay a cloud bill, right? Mm-hmm. So, and knowing from experience, especially if you're a startup, you get these free credits from the cloud providers. It's $100K. Initially, it seems like a lot of money, but when people think stuff is free, they start using it, right? And all of a sudden, you're ramping up slowly, and your spend ramps up to $15K, $20K a month, and all of a sudden, $100K are gone. and now you're left with a 15K monthly AWS bill, right? So I feel like this could be a way to extend my runway by a lot.
That is exactly true. Yeah. So, I mean, typically we're seeing these different phases of development, right? So, code is developed maybe on a local machine. Then most engineering teams maybe have some dev sandbox environments in AWS that they can use for individual development, and then there's maybe staging and production environments. And with LocalStack, you can literally sort of, for the most part, eliminate some of the cost of these dev accounts, of these sandbox accounts in AWS, which, as you mentioned, they accumulate costs. You have these problems of idle resources that are just not being cleaned up properly. So I think there's some tools and providers who are really focusing on, giving you analytics and automatic cleanup mechanisms to just make sure that the cloud bill is not getting out of hand. And again, with LocalStack, it's just conceptually, you don't need to worry about these problems, right? Because you never have any cloud resources per se. Having said that, though, you still want to have a pre-production staging environment that mirrors the exact environment that you operate your application in as the last phase before you push it out to production. So LocalStack is not intended to replace that piece, but certainly the local and the CI analytic, the CI pipelines part of executing your tests.
Right. So it's almost like, I mean, the classic structure is dev, test, staging, prod.
Mm-hmm.
You do all of that in the cloud, right? And ideally, it sort of like spills over from one stage to the other. But you're adding another step to it, which is like local, right? So it's always like local, test, staging, prod, right? So it's a new way of, that's like, it's an emerging layer, a new layer at the very beginning of my development cycle.
Exactly. Yeah. So, I mean, and the interesting thing is, if you look at resources like, I don't know, so cloud billing is usually like usage based. So either it's the billing unit is sometimes an hour. So, for example, with Kinesis, you pay 1 shard hour. And the interesting thing is, like, if you run a lot of tests and these tests are doing like creating and deleting resources all the time, even if they're just active for a fraction of a second, you still pay the entire billing unit, which, for example, is an hour. And that, again, like, just accumulates over time, especially if you have this case of testing frequently and creating and deleting resources frequently.
Oh, that's an interesting point, because the billing increments for some services are 1 hour. But if you even just run it, let's say you spin up a test takes, I don't know, 2 minutes, 1 minute, 5 minutes, I don't care, right? Less than an hour, you pay for the full hour. You
That's
do that
exactly
test
right.
again, you again pay for the full hour.
Yeah, exactly. Yeah. So it's interesting because it seems like, I mean, that is not that is the case for certain services, certainly not all of them, but it seems like there is still a bit of a gap in terms of, like, how does this pricing, which is usually really optimized for production workloads, how does that actually translate to development workloads and just frequent testing, frequent creation of resources and so on.
Mm-hmm.
Yeah.
And I'm going through my notes. I thought the billing part is fascinating with the billing increments, right? Because it's like sort of a double whammy, or a double benefit that you avoided. So a lot of including risotto on our own, right? There's a lot of product alternatives, open source alternatives to what the cloud providers offer to a lot of
Mhm.
these services. And then usually the argument as well, because we're a startup, we focus on this one specific problem, we do it much, much better than the cloud provider, and it's open source, and we work across all the clouds, by the way. That's usually the narrative.
Yeah.
There is no alternative for LocalStack offered by AWS or GCP or Azure, to the best of my
Mhm.
knowledge.
Mhm.
There's none, right?
Yeah, yeah, that's interesting. I mean, the alternative really is to just use the real clouds. I mean, to be fair, like, there's been a few initial, like, there's a few emulators of individual services that have been put out by most of the major cloud providers. For example, AWS has DynamoDB Local, which is a tool that emulates DynamoDB locally, or Step Functions Local. So there's a few tools, but they're kind of fragmented and very sort of for individual services. And the power of something like LocalStack comes with the integration between the services, right? We'll actually maybe see this also in the demo. If you put a file to S3, to an S3 bucket, and that triggers a notification, you can call a Lambda function from there and then put in a message to SQS, and that triggers something else. Like those integrations are the ones that you typically have in an application. And that's really what we provide with LocalStack as well. So yeah, as you mentioned, there's no sort of, fortunately, no direct competition to what we're doing. But obviously there's, some projects forming here and there, which are also doing similar things. And frankly, we're also, building upon other open source projects, which also have made a great work on just, putting out emulators and so on. So there's certainly, but it's mostly community efforts, right? So as you mentioned, it's currently not something that is orchestrated by the cloud providers.
Yeah. Well, I mean, it makes a lot of sense, right? The cloud provider's business model is that you run resources in their cloud and then you pay for it, right? If you're doing it locally on your stack, there's nothing they get paid for, right? So, but I mean, look, just looking at the traction in your repo and your users, it's hard to ignore you guys. So I'm sure AWS or GCP or both have thoughts about this and are probably approaching you and trying to have discussions. But we'll leave that for another podcast. So one thing. So let's switch a little bit to the underlying tech. There are, I don't know, if you believe Amazon's website, AWS website, there are over 200 AWS services. I think like it's something like 265 or 280, right? And that doesn't even count all the different SKUs underneath, right? And it goes into, if you just look at the items on a cloud bill, it sometimes goes into the tens of thousands. So how do you build out support for all these different services, and what does that entail? What's the work behind it? And if you want to show something, please share your screen too.
I think so. That's, I think, a great sort of opportunity to share my screen and show you, maybe walk you a bit through the documentation on our website. So if you go to localstack.cloud, that's our main kind of landing page, where we have just a few details about, very high level, what we do, who our customers are, and our solutions. We have these three core pillars: core cloud emulation, which we talked about so far. Then we're also increasingly focusing on team collaboration features. We'll talk maybe about that in a bit. And then also enterprise integration. One thing I would like to point out is our docs page. So that's linked from up here, and it's also docs to localstack.cloud. And here you find a wealth of information about the different integrations that are available. So for example, if I can just take a quick look at, this is the ecosystem of tools that we're trying, that we're actively maintaining. So things like Terraform, Pulumi. We sometimes have simple repo scripts around those tools to make it easy to deploy your resources against LocalStack and local machine. And then there's other things like the cloud development kit, for example, or the serverless framework, and many more integrations. So that is a great resource if you want to sort of take a closer look. And in regards to your specific question about the services, so these days we're trying to be very transparent, also try to document what the coverage level for the different services is. And we've come up with a scheme of 1 to 5 stars. And then we have a very comprehensive list of all the services that we provide, whether they are part of the community version or pro. So that's our commercial tier. And then also what's the level of emulation that's provided. And we can actually drill into, let's say, one of the API gateway here. We click this link, and then you actually get a detailed list of all the operations that are provided, whether they're implemented, and also this small sparkle. I'm not sure if you can actually see this on the screen, but this means that it's basically covered by one of our parity tests that are really making sure that the requests and responses are exactly sort of matching what AWS is providing. So that's kind of the additional stamp that we get on top is, this is really a well-tested API method, for example. And this is something that everybody sort of can look up here. Obviously, the list is growing. We're auto-generating this list from our CI tests. Then if you go to show missing, you'll also see a few things that are currently not yet supported, which we're going to be adding soon. And this is basically how we try to track what's currently supported and what's not yet. Does that make sense so far?
Yes, I'm just waiting for more. Yeah, great. This makes total sense, right? So okay, so you take a new specific service, you look at the services documentation. In AWS's case, it's probably Bodo 3, right? And then you try to emulate the API calls and the API responses. That's
exactly
roughly
yeah.
it, right? Makes a lot of
And
sense.
there's a whole sort of sequence of steps involved when we onboard a new service, and I can definitely recommend, if I go back to our website and to our engineering blog, I would love to point out this LocalStack and AWS Parity Explained blog post from our team. Here you'll find a lot of really detailed insights into our we call it the AWS Server Framework, which is basically a way to generate, as you mentioned, from the Bodo core specs, generate code from the API specifications, and then make them available to the internal engine in LocalStack to do all the request processing, response serialization, and so on. You can actually see in the screenshot here, this is a screenshot from one of our GitHub repositories, where we have basically a bot that's automatically scraping the Bodo core specs and checks for any changes that were happening in the API specs, and then automatically updates the specifications on our side. So here you can see the generated Python code, and you can see the changes that were introduced by the latest API updates on AWS side. So we're really sort of trying to get very systematic with being on par with AWS, and also implementing it properly, and then also documenting it for the community.
Right. So that's really part of your secret sauce, right? Even though it's open source, there's the secret sauce, like doing all that hard work and the heavy lifting in the background.
Absolutely, yeah. So, and again, we sort of, like, every project builds on the shoulders of giants. So we obviously also, leveraging great software out there that's part of the whole LocalStack ecosystem. But essentially, yeah, if it boils down to like the secret sauce, as you mentioned, like really understanding what are the common patterns in emulating services, like in general, right? So you always have the issue of you're dealing with APIs, right? And you need to map incoming HTTP requests to internal service implementations. And then in your service implementation, you have some kind of a state management, right? So you store the states. And then you sometimes spin up external processes. So, for example, as I mentioned, like the core LocalStack is actually running in a Docker container. But then you sometimes spin up external processes, like, for example, an Elasticsearch cluster, or I don't know, even like a Postgres database or something. And this whole lifecycle management of running all these processes, making sure the ports are exposed and so on. This is, I would say, really the secret sauce of what we provide. And also keeping it lightweight in the process.
Yeah. How often do these APIs change? And when something changes, how does it change?
Yeah, it's a great point. So there is so they change quite frequently. So we have a weekly essentially update of these APIs, and every Monday morning we basically get the updates in, and we check if all the tests are still passing, and then we can merge them, or we need to fix something. Usually it's addition to, like, adding new APIs. Sometimes there's also just documentation changes and updates. In rare cases, things also get removed or renamed, but that's actually more like the exception. And then once, like, and then the process from here would usually be, we see, okay, there's a new API method here, for example, and then we would start implementing it and adding a parity test. And that is something I also would like to briefly show here in this blog post. So essentially, what parity testing means is that we run our integration tests, and we run them 2 times. Once against real AWS, and then we record all the requests and responses. We store them to a file, and then we run the same requests against LocalStack, and we compare essentially whether the correct response has been returned. Now, as you can imagine, there's a few things like, and this is actually what one of these recorded snapshots looks like. So you can see all the details from a create Lambda invocation, for example, right? And the interesting thing is you see some aspects here that use these placeholders like function name or also the region and also some other maybe generated IDs or timestamps. So there's obviously date, for example, here. So we need to make sure that some of the fields are not being compared because times are always different and some IDs are also different, right? So that's built into our parity testing framework in order to make sure that we have the correct comparison, basically, with what was recorded and what's implemented.
Fascinating.
Yeah. So those are, again, like I'd love to point you to the details here. And then also you can see here, like this is the report of one of the parity tests, things that are missing, things that are extraneous, like they shouldn't be there, and things that have changed, for example.
Yeah.
Yeah.
So I'm going to go back to the secret sauce and the value add. Obviously, having a local development environment, a full-blown cloud environment on your local machine due to the parity, but really you have humans looking at the individual APIs of those cloud services, develop an understanding of how those APIs work,
Yeah.
reflecting that in your product, and then building out the test suite and bringing it to parity and doing the parity testing so that you're always like I'm going to pick a number at anywhere between 95 to 99% parity. And over time, probably you're going to get to 99 or 5 nines, whatever it is in terms of parity.
Yeah. Exactly. Yeah, exactly. So this is really sort of, so we are, as a team, we are aware that the obviously the surface area is immense, right? There's so many services supported in AWS. I think you mentioned it before, something in the excess of 200 services or more. But what we also see is that there is a core set of services, I would say maybe 50, 60, 70, that the ones that are really very frequently being used. So it's a finite surface area, which is good for us. So we sort of are getting better and better in terms of getting to this parity. And as you mentioned, sometimes it's really about reverse engineering what is the internal behavior and semantics of the service, right? So we do this by looking at the documentation, for example. That's usually the first starting points. We look at the API specs, but then actually we also just simply run the parity tests, this is the ultimate truth. What does AWS really behave like? Because sometimes there's also discrepancies between what the docs say and what's really happening. So, for example, if you take SQS, the simple queuing service, that's a good example of a service that has lots of semantics of how messages are being queued, what is the visibility of messages, timeouts, and so on. And we essentially built it up from scratch. So we previously started with an external implementation. Now we have our entirely internally written one. And for this one, we're quite confident that it has almost 99%, almost 100% parity with the real thing, because we've covered so many edge cases in our testing as well.
I'm smiling because you're telling me that the API behaves differently than the actual AWS docs say. You don't say, really? That happens?
Exactly. Yeah, I'm
all
sure
the time. Yeah,
you know a lot about that as well. Yeah, exactly.
Yeah. I just like no blame on them, right? But it just happens all the time. Fascinating. And but those tests, they're not open source, right? They're not part of your GitHub repo. That's your internal
They are actually for the most part. So if you just take a quick
as
look
well.
at,
Okay.
yeah, definitely. So just go to LocalStack. That's our main repository, which you can find here. And if you just go to test, and then we have simple unit tests, which usually don't require spinning up the entire server, but just a unit test. But the majority of the interesting tests are in integration. And then you can find for the different services, I don't know, because we talked about API gateway before, or maybe let's take SQS. That's a good example. Test SQS. You also see the snapshot file here, right? So that has been reported. And then we just can go in here. And let's take a look at the lines of code. As I mentioned, SQS is really, really well tested. So we're somewhere in the 3,000 lines of code. And when you see these markers like PyTest mark AWS validated, that for us means this test has been sort of essentially parity tested against AWS, and we can make sure that this behaves properly, right? This functionality. And this is just a very comprehensive suite of different functionalities that we're testing there.
Yeah, yeah.
Yeah.
So from an open source aspect, and look, I get this question a lot as well. I don't know if you get it, but it's like, oh, can't just somebody come and rip you off and copy the code and like, sure, yeah, it's right there. You can copy the code, and
Mhm.
depending on the license, here's how you can use it. But because there's so much, let me call it tribal knowledge within
Mhm.
LocalStack and internal documentation
Mhm.
and the actual
Mhm.
humans who have knowledge about these services, and you're running all these tests yourself, and because these services and APIs change all the time, even if I take a snapshot today, it'll look different 5 minutes, 10 minutes later, and you're lost.
Exactly.
So
Yeah, that's exactly right. And I think it's really sort of this ongoing engine that's behind it, and that really makes sure that you have the support, that you sort of get these updates of the services, that new things are being added, that your issues are being addressed. So for example, in this issue tracker here, this is our like one of the main sources where people can report if they have any questions or issues. And the team is just behind this and just constantly churns through this backlog and make sure that things get better and better. And I think this is really where like the let's say the competitive advantage also is. Also, I think in terms of the integrations that I briefly mentioned before, it's becoming more and more easy to use LocalStack with all these different tools, right? Terraform, serverless, like Pulumi, and so on. And we're just establishing certain patterns of how local cloud development is being done. For example, one good case is our canonical port 4566. So this is probably LocalStack users are aware of this and what it means. It's basically our gateway port that is the central entry point into the system. So a lot of our tools and clients are just using that localhost 4566 as the entry point. And it just at some points becomes almost like the standard. Okay, this is your local API, right? It runs under this endpoint. And I think all these aspects combined just we're not too concerned about sort of the open source side of it. It just open source always nurtures great software, great collaboration, and just uh, allow us to also
precisely.
dominate the space.
Precisely, yeah. And I mean, I'm looking at your, maybe you can go back to your main repo and let's look a little bit about at your metrics there.
Mhm.
um, GitHub stars.
Yeah, right. Yeah.
GitHub stars, the number of people watching, and forks. I mean, you have a Slack community as well, so there's
Mhm.
lots of participation and community support. Can we talk about this a little bit? If you go back in time and 40, like almost 44K stars, which is mind blowing. How did you get there?
Mhm.
And let's say, how did you get the first 100, the first 1,000, the first 10,000, and
Mhm.
what changed? How did it grow to what it is today? And by
Yeah.
that I mean your repo and your developer community and the activity within that community.
Yeah. So we do have a maybe if I can just briefly try and browse this here and see if I can find it. But we actually we shared some numbers in a community event that we were hosting. Sorry for to quickly find this here. It's probably this one. Yeah, this was kind of the slide from our first community event, and I think there we tried to show a bit like the history of how it all evolved, and maybe that's something that could be interesting. Yeah, exactly. So here we're basically seeing the GitHub stars over time, and you can see that in 2016 there's this is generally what we refer to as kind of the bootstrapping phase, very early days of LocalStack. And then there was one event which was quite interesting. So Jeff Barr from AWS put a tweet out and said, "Hey, look at this thing that is LocalStack," and this was a huge bump initially. And from then on, it was kind of growing over the years. Had this early adoption phase in kind of the middle here, where it just continued growing and just adding new services, working with the community. And now I guess the last bit here is really sort of now the last year or so, year and a half, where things are like just dramatically speeding up. We're getting much more professional with this parity testing and also having a team behind LocalStack. So this is sort of a bit the story of how it evolved. But certainly this initial event here was quite useful for us. It was all over the internet.
We at Risotto, we we're at I think we just crossed the 1,000 GitHub stars mark after about 9 months in the market. But we had the same curve. Jeff Barr initially tweeted, which is what gave us the initial 70 stars. And I feel like shout out to Jeff Barr. He may not know that he is behind the success of many open source products, right?
Yeah.
Because his people respect him, people follow him. He
Mhm.
probably knows AWS better and its services better than anyone else in AWS. Um, so fascinating. Okay. And so the bootstrapping phase, yep, you get the early users. What did you do in the early adoption phase to work with your community?
Yeah, so the early adoption phase was quite frankly also, I guess, just being the main maintainer of the project here for some time. I was sort of involved in a bunch of other projects as well, so it was kind of running a bit sort of on the side, still making contributions and seeing it grow. But I guess this was a phase where we got we certainly got contributions from the community. Also, actually onboarded a few sort of freelancers who were kind of then really working more closely with the project. And we also, for example, established an open collective, which is basically a donation system where we were then able to pay out a few freelancers who were working on the project. So this was basically this. But I would say it was also wasn't leveraged to the full potential of what it could have been. It really then sort of started later on in this phase, in the growth phase, simply because there was also other things to work on during that period of time.
Right, right.
Yeah. So that's yeah.
Okay. And how much, like, what specifically does the community do for you? I mean, we looked at the issues and
Mhm.
do they in what form do they contribute today?
Yeah, right. So I think a lot of the great work we get is from, first of all, issue reports, which is extremely valuable for us to have a reproducible sample. And we also try to make it sort of easier. So, for example, when you create a new issue here, you get like this, this workflow. You can, is it a bug? Is it a feature request? And then basically in the bug, you can fill out, the information, which version are you using, and so on. So this is extremely valuable for us to be able to quickly replicate an issue and then get it resolved. So that is one thing. We do also get pull requests from the community. We very much actively want to engage the community. We also shepherd PRs along the way and in the process, and just make sure that folks get them over the line, that all the testing is in place, and so on. So the team is very actively also behind the whole pull request workflow. And then also we should mention also the sort of third-party dependencies that we depend upon, right? So again, built on the shoulders of giants, where a lot of cool projects like, I don't know, Flask, and there's a project called Moto that we depend upon, which uses also, does some great work on emulating some of the CRUD functionalities of APIs mostly, and just a lot of other things that we use, but we also contribute to, right? So we also try to actively contribute to these upstream or downstream projects.
Mm-hmm, mm-hmm. And so this journey now started when? 6 years ago, 7 years ago?
Yeah, about that time. So 2016, 2017, around that time.
Yeah, yeah. And in your journey of building LocalStack to what it is today, what are some of the lessons learned? What would you do differently?
Mhm.
And what would you have done faster? Now, in hindsight, we're all smarter, but let's talk about these things that make us smarter.
Yeah, certainly. So I mean, one aspect is certainly just time. Maybe just entering the growth phase at an earlier stage would definitely have been helpful. So I think we're still in a good spot today, but it feels like these early indications were already so strong that something like this is needed, that we could have just gone all in even sooner in time. The second thing is obviously we've evolved a lot how the project itself is structured, and like the whole architecture of the software, right? So it has grown
Mm-hmm.
quite organically over the years, and now that we have a team of actually like around 20 engineers in LocalStack, we had to prepare the code base in a way for it to become scalable and put in a lot of new best practices and how we do things. So this has evolved a lot. I wouldn't really say this is a learning in the sense that what could have been done better. It's just an interesting evolution of the code base, specifically in the last 12 months or so. And and then I guess I think those are the two main issues. And then certainly, so sort of also one thing we have to do on an ongoing basis is kind of the opinion making, like going out to the community, because even though we have quite a good visibility in terms of stars, there's still basically two camps, I would say, of people who say local dev is amazing, or local cloud does not work, right? So, and kind of still continuously putting out content, making the opinion making piece, and just getting people on board of this journey, and really making sure that they essentially, this is a tool that essentially every cloud developer out there could be using and should be using. So I think this is some of the things we focus on now as well, in terms of going out to the community and doing marketing more proactively.
Which I think is a way of describing category creation, right? You just named it local development, right? Like that's the category you're trying to create, or you already have created, looking at your traction.
Absolutely, yeah, totally. But there's still obviously, like, you create a category and then still you have some naysayers or people who don't believe it.
Of course.
And also there's, like, again, I'm totally empathetic for everybody who's been using LocalStack in some of the early days where things were just not working that well, haven't been as performant as they are now, as smooth, as well supported. So I would encourage everybody to give it a try and take a look at it with fresh eyes, basically, today, as compared to the past.
No better time than the present. Do you want to give us a quick demo?
Yeah, that's a good segue into a short demo.
Let's do it.
Great, awesome. So what I'm going to do is, and apologies, there's lots of things happening here, but what I would like to, actually, let me switch over to this terminal here. And before I start everything up, what I'll do is I
do want to point out you're on the screen, right? So
I'm on the screen.
Well, we're looking at your screen, right? And
exactly.
If we need to,
yeah.
Okay.
But before I start everything, I would like to just open a set of slides for a short demo that was giving at a EuroPython conference recently, and this is just a nice example that we can take a look at. So let me just pull up the sample. Where was it? It was somewhere further up here. Sorry to find it. Where's the demo? Loading. Yeah, this one. Okay. So what we would like to demo is basically a simple application where you have an S3 bucket, and we assume that we use this S3 bucket to push logs in a JSON format, right? So some client application is pushing logs. Then the bucket triggers a notification and triggers a Lambda function, which receives the logs and does some processing. And then if it finds certain information in the logs, it will actually trigger an alert to an SQS queue, which is then received by a client. So relatively simple producer-consumer example in a sense, and we can now deploy this with LocalStack. We will use Terraform to define this infrastructure and then deploy it and run it locally. So switching over to my terminal here, I hope you can see the font size. Okay, so I'm going to start LocalStack here. I've started up with debug log, so that's why you see all this pretty verbose output. If I scroll up here, you can see the banner, which kind of really like the welcome message. Hey, and I think somewhere it prints ready. Ready means it's up and running and now available. Switching over to this other terminal here. So what we can do, the first thing is we can run AWS local commands. So AWS local is basically our wrapper script for the AWS CLI. So we can create a bucket, test 1, 2, 3, and then a bucket has been created. And you see on the left-hand side, it produces some output for the service invocations that are taking place. So that is really kind of the very plain vanilla of just interacting with LocalStack in general. So now, with regard to the sample specifically, so let's take a look. I'm just going to remove the old Terraform state here, and then let's take a look at this main.tf file. So this is the Terraform configuration that defines the sample we just looked at before. So we have a bucket resource. We have an SQS queue, which has like an IAM policy associated. We have a Lambda function. I'm going to take a look at that in a second. So that's the one receiving the events from S3. And then some more IAM roles, and then the actual bucket notification, which links the Lambda function to object-created events from that bucket. And that's really pretty much it. So not too complicated. And what we can do now is we have this script called tflocal. And tflocal, again, is a wrapper script around Terraform, which basically just deploys the changes locally. So I can do, let's actually start with an init. So tflocal init, just make sure that the modules are all downloaded properly. And then we can do tflocal apply, which will now, first of all, generate the plan. So Terraform generates the plan of what needs to be deployed. And we say yes. And it's now, you can see on the left-hand side, it's now churning through the API calls that are being done to create all the resources. So the S3 bucket, our Lambda function, the SQS queue, and all that. And you can see very detailed outputs here that can also be reduced a bit, the noise, but it's useful for
we see all the yeah, there you go.
Yeah, exactly. So for example, this, I don't know, get bucket notification configuration or Lambda add permission and all these things. Okay, so now this has been deployed. And if you look again at the sample, what we want to do is we want to put some logs into the S3 bucket. So let's take a look at what these logs look like. So there's this example app.log. And these are just messages with a timestamp, some message, and a certain CPU level. So here the CPU says 60%, 90%, 30%. And we're going to use those in the Lambda function to trigger the alerts, basically. So fairly simple, just a bunch of log lines in JSON. And then let's take a look at the Lambda function itself. So this is written in Python. And what we'll see here is this interface that most people will be familiar with. You get the event and the context. And then we can basically have a for loop that goes through all the records and filters if the CPU threshold is greater than 80%, then we have a critical CPU alert. Otherwise, it's just high CPU if it's higher than 70%, for example. So fairly simple. And then we send this message to SQS where we can consume it later on. So what I'm going to do is I'm just going to, and I have a little cheat sheet here. I can do, so in my run sh, I can copy this, which basically just copies this file to the S3 bucket. And what you can see now is that it's actually triggering the Lambda function. It's actually already finished. So between start and end, it triggered the Lambda, and it was basically printing out also this hello world that was part of the Lambda.
Yep.
Now what we can do is we can actually receive these messages from SQS. So we received the first one. I think there should probably also be, no, that's only this one, only the critical one. But yeah, basically you saw that it's just receiving the message from SQS. Now, one interesting point I want to briefly highlight is the ability with this hot reloading that I mentioned before, right? So if we want to make a change to our Lambda function, so here maybe we say hello some engineering, and then I will basically just copy the file again. Without doing any redeploy of the Lambda function, it now actually has the new content here in the output.
It's like a hotfix.
Yeah.
Yeah.
So again, fairly simple example, but kind of showing a bit the end-to-end. Maybe just one more thing I could briefly showcase is in our app. So we have a simple web UI where also you have what we call a resource browser, where you can then navigate the sort of the resources that were created. And just going to take a quick look at that. So you go to app.localstack.cloud, you can create an account there. And now in this resource browser, we have all the different areas. And for example, now we see our SQS queue with the details and also the message actually that was put in there. We can look at the Lambda function, for example, with the logs. Should also give us the logs from the output. So this is just an easy way to showcase and give insights into what's happening in the local machine, basically.
Yeah. So you just showed us a full set of Terraform workflows to deploy that infrastructure,
Mhm.
and then build your, I'm going to call it a logging app, right? So
Mhm.
that log, if you can go back maybe to, yeah, there you go, right? And so you just had a full blown Terraform workflow locally on your machine, and then you showed us how I would actually receive that alert from SQS. So,
Yeah.
and this was what, 5 minutes with explanations and everything.
Yeah, pretty much, yeah, and like never really talking to the real cloud. In fact, if I try to deploy this, if I did a Terraform, so if let's remove this again, the state, and then I do a Terraform apply, and again, this is coming where sort of people are hitting issues. So currently, I don't have an AWS credentials configured in this terminal, so I cannot even deploy it to AWS, right? So yeah, basically making it just all locally.
So
Yeah,
you're blocked. You'd be blocked.
yeah,
Yeah,
exactly.
fascinating. Well, this has been a fascinating discussion. Did I anything I forgot to ask, Waldemar, about LocalStack that we should cover?
Yeah, it seems like we covered really sort of a really quick walkthrough of both kind of the history of the project. Actually, there's maybe one more thing I would like to briefly share if we have maybe 1 or 2 more
Yeah,
minutes. And this
we
is
do. We have that's the nice thing. We have endless time on this podcast.
That is fantastic. That's great. So one thing I would like to point out is this recent blog post about cloud pods. And the reason why we think it's cool is because it's an entirely new way of thinking how to deal with state. So state as in the resources that are created in your instance, like the SQS queue, the Lambda function, the bucket, and so on, and how this can be managed and also shared in your team. I just want to briefly show this one image here. I hope you can see it. So in
Yep.
LocalStack, we have one mode which is called persistence. So basically, so by default, when you start and stop the instance, the state is ephemeral and everything is deleted after you do a restart. The first step is you can enable persistence, which means that any interaction that you do with the APIs is stored to disk, to a volume, and then once you restart the container, you restore the entire state and it's back up again. The next evolution of this is what we call cloud pods, which is now basically a way where in the running instance, right? So in your running Docker container, you can do a commit operation, which is similar to a git commit, which stores the state, a snapshot of your state to a local storage. And then you can later inject the state into the instance to have the exact same state. And then you can obviously also push and pull the state to a remote backend in order to make sure that it's actually, you can share it with your team members. And we think this is actually pretty exciting because it enables a lot of new use cases in terms of how you can collaborate with your team. It also gives you a lot of insight into what's the content of these cloud pods. We talk a little bit about different merge scenarios because obviously once you now have an existing state and you inject an additional state, you need to think about how do we merge these states together, for example. And there's a bunch of more descriptions how this can be used for your team collaboration flows, basically. And I'd really like to encourage everybody to take a look at that and give us feedback if that really helps your workflows in terms of how you develop cloud applications.
So that's the evolution of LocalStack, right? What started out as a project to be productive for an individual developer to be productive on a train ride is now shifting into a world where you're trying to have more than one developer collaborate on things, and they can do that because they can share state, and that
Exactly.
way they're always working on the same thing. Yeah,
Yeah. Yeah.
fascinating.
And this is really something that is, at least in our view, is quite a bit of a game changer because what we already have seen is obviously infrastructure as code with Terraform and all these great tools. What hasn't been so much established yet is this notion of almost like infrastructure as state, which we're sort of a bit coining here, this term, that you literally sort of, instead of having to do the creation of all the resources with infrastructure as code, which is certainly the first step, but once it's been created, you can literally just work with that state and just basically inject it into different instances and so on. So Terraform is already doing this in the sense that you have this local TF state files, which are basically a cache of what the state is in the real cloud, just mostly for caching reasons. But in our case, it's really sort of literally taking the exact state of the application and making it available for sharing and collaboration. So we're actually pretty
Yeah.
excited about this and hope that the community is as well.
I'm excited about it, just looking at it.
Yeah.
Awesome. Waldemar, this was fantastic. I think we learned a lot here. Lots of sound bites and tidbits. What's the best way to reach you if people want to work with LocalStack?
Yeah, so certainly so we have a discourse page. It's discuss.localstack.cloud, which is just great to ask any questions or get a feeling for our feature roadmap as well. We have a Slack channel. You can find the invite in, I believe, on the website, on the GitHub repository. You'll find get involved, and you'll find the link to the Slack channel. So this is really the best way to interact with the community. We have, I think, something around 10,000 people who are invited in the Slack channel and some very active members as well, plus our team. So Slack is really sort of our primary means for communication. And then also I would like to point out our community meetup. So we have actually one coming up, I believe next week well, depends on when this session will be aired, but it's going to be on the 15th of September. And it's basically a monthly event where we also want to invite speakers from other companies and like the partnerships we're starting. For example, now we are hosting a talk by Atomic Jar test containers, which are sort of operating in a similar space like we do. And test containers really integrates really well with LocalStack, and we want to have a short talk about this. Would also love to hear more about the risotto LocalStack integration that we briefly brainstormed before the session. So yeah, so that's a great way to get in touch with us.
Yeah, fantastic. All right, Waldemar, thank you so much. And I feel like we should have, I always say that after every episode, we're going to have a version 2 of this podcast in a year out, and then we'll hear the progress you've made. Fantastic. Thank you so much. So this was Waldemar Hummer, CTO and co-founder of LocalStack. Thank you, Waldemar.
Thanks so much for having me. Have a great day, Lars. Ciao.
See you. Bye.